How will you do the preferential trip and reverse power trip test? Reverse power trip test. Purpose: the reverse power trip is a generator protection mechanism designed to prevent the generator from running as a motor, which would mean it is absorbing power instead of producing it. This typically happens when the generator's power output goes below a negative threshold, usually set at 8 to 10% of the nominal load. Setup: identify the nominal load of the generator. For example, if the nominal load is 2200 kilowatts, the reverse power trip setting might be at minus 220 kilowatts, 10% negative. Prepare the system by putting the control on the main switchboard and selecting the generator to test, example generator number 2. Procedure: reduce the load on the generator gradually and carefully. Monitor the load decrease until it reaches the reverse power trip setting threshold, example minus 220 kilowatt. Once the load drops below this threshold, the reverse power trip circuit will detect the negative power flow. The breaker will trip automatically, disconnecting the generator to protect it from motoring. Precautions: reduce the load slowly to avoid sudden disturbance. Be aware of the exact reverse power settings to avoid nuisance tripping. Ensure another generator is running to take over the load during the test. Preferential trip test. Purpose: the preferential trip protects the generator or bus bar from overload by tripping non-essential loads first to prevent blackout and maintain essential systems such as propulsion and navigation. Setup: the preferential trip system has two stages, first and second trip. Testing usually focuses on the first stage. Adjust the load percentage limit on the power management system to simulate an overload condition that should activate the preferential trip. Procedure: manipulate the load on the PMS to exceed the set preferential trip limit. Observe the alarm and monitoring system indicating the preferential trip is activated. Verify if the breakers for non-essential loads, example fans, reefers, trip accordingly. If breakers do not trip, check the timer relay and the associated contacts. Measure voltages at relevant terminals. If the timer contacts remain open despite activation signals, the timer relay may be defective and must be replaced. After replacement, repeat the load manipulation to confirm the breaker trips as expected. Troubleshooting: use the manual to understand the logic and wiring of the timer and contactor circuits. Measure voltages at timer and contactor terminals to verify correct operation. Replace faulty timer relays if contacts fail to close. Ensure the preferential trip activation does not affect essential equipment. Outcome: when the preferential trip activates correctly, non-essential load breakers trip, reducing load and protecting the system. Essential operations continue without blackout, ensuring vessel safety.